Let's start our discussion on the real number line by first discussing what makes up a real number. So there are different sets of numbers that you're used to seeing. Let's talk about those sets very briefly. So the first set of numbers we call the natural numbers. The natural numbers are usually denoted with a capital N, and typically in books you'll see it with a bolded N. So it'll look something like that. This set of numbers I always remember as the set of numbers that represents the way a child would count. So if I asked my 5-year-old son, if I said, start counting, he would start at 1, and then he would proceed to 2, 3, 4, so on and so forth. So the natural numbers start at 1, and they increase forever. There is no stop. There's no end to the natural numbers. They just keep on going. The next set of numbers are the integers. And the integers are usually represented by a bolded Z. And they are all of the natural numbers, plus some more. They are all of the additive inverses of the natural numbers. So meaning all of the negatives. And the number 0. This set is also infinite. But both of these sets really are what we call discrete, meaning that each of these values in here doesn't have a number necessarily in between consecutive values. So between 1 and 2, there is no integer between 1 and 2. The next set of numbers, which is the rational numbers, that set is denoted by Q. That's as good as bolding my Q is going to get. Now that set of numbers are all the numbers, all the integers, written as a fraction. So these are fractions. With integers as the numerator, the top, and the denominator. So for example, some of the, and I can't write out all the rational numbers, and the reason I can't even write them in this notation up here is because they're what we call dense. For example, if you take, let's say, a rational number like a fourth, and you take another rational number like a half, there's always a rational number in between them. Now that wasn't the case with the natural numbers or the integers. Okay, but the rational numbers have a number in between. In fact, I can find it by taking, or I can find there's an infinite amount of them in between here, by the way. But if I take a fourth plus a half, and I divide that guy by 2, I'll find the number that's exactly in between them. So that's a fourth plus 2/4 divided by 2, or 3/4 divided by 2, which is 3/8. So there's another rational number in between my initial 2 rational numbers. So since I can always find one in between 2, that means that they're dense. Now there are some numbers that can't be written like this in terms of a fraction of a ratio of integers, and those we call the irrational numbers. Now, let's actually write out the word number here. Now some of those numbers are what we call algebraic, the others are transcendental. That's really neither here nor there. Just remember that the irrational numbers are numbers such as square root of 2, pi, e, so on and so forth. You're used to seeing those. And if we take all of these numbers that we've just talked about above, and we put them all together, then we get what we call the real numbers. And so we've devised this line to represent the real numbers, and it's the real number line. Now, every point on this line is representative of one of the real numbers. So we usually start out by grabbing our origin, which is where 0 occurs, and by marking off typically integer values. But any point that you grab on this line, let's say this guy right here, that is a real number. And this guy over here, that is a real number. And so is this guy. And so is this guy. They're all real numbers. Okay, so that's our real number line. Now the next thing we want to talk about is this new notation. And this new notation is called delta x. And so this, even though it looks like two separate things, is just one variable. Okay, and so we read it as delta x, or sometimes people read it as the change in x. And the reason they read it that is because this triangle typically we use as the symbol for change. So what we're talking about when we talk about delta x is we're talking about how does x change. So what we need to do is we need to grab two numbers on the real number line, and we'll call these numbers, we'll call these guys the x values. Okay, they're on the x-axis. Okay, so then we can also look at it as the y-axis as well. We look at it up, down. So we'll look at the left and right, our horizontal axis. We'll call it the x-axis. Now, if I grab two numbers on there, let's delete these guys. Whoops, there goes my whole number line. Let's put it back. Okay. Now let's grab two guys on there. Let's say we grab the numbers 1 and 3. Well, if I started this guy over here, we'll call this guy x1, and we'll call this guy x2. If I go from x1 to x2, then my delta x is defined as when I read this, guys, it's how does x change? And so our delta x here is going to be equal to, the easy way to do it is take x2 and subtract off x1, which is 3 minus 1, or 2. So my change in x from 1 to 3 is 2 units. Now if I go back the other way, if I reverse directions, okay, let's do that in a different color. Let's do that in green. Well, here the green delta x is I'm going from x2 to x1. So of course I have to be negative, right? So this is going to be x1 minus x2. And our x1 value is 1, our x2 value is 3, so that's negative 2. So our delta x can be positive or negative. We can start to think about this in terms of distance, and that's what I'm going to talk about in the next video. But for now, we just need to think about delta x as how is x changing. Likewise, we can talk about the y-axis. And if we think about the y-axis as representing all the real numbers again, with 0 being here, 1, 2, 3, negative 1, negative 2, so on and so forth. If, let's say I'm going, oops, there's supposed to be a negative in front of that guy. If I go from negative 2 to positive 3, my delta y, if this is the y-axis, the change in my y is from negative 2 to 3. So I go 3 minus a negative 2. So basically, you grab where you went from, and subtract where you started from. So this is 3 plus 2, or 5 units. And so the change in y is 5 units. 1, 2, 3, 4, 5. Likewise, if I reverse the direction, it'll be a negative 5 units because I'm going towards the negative direction. So you got to think about, are you heading towards the positive or are you heading towards the negative?